Hi and Assalamualaikum everyone. So at the end of this video, you should be able to identify minimum and maximum points by using the first and second derivative tests. Okay, now let's take a look at the first example. So question asks you to determine the relative extremum of the following function by using the first derivative test. So what does it mean by this question? Okay, so basically, relative extremum is either relative minimum and also relative maximum. So this question asks you to determine what type of stationary points that you have already found. Okay, so the first thing that you need to find is your first derivative, which is equal to 6x squared minus 24. And then you need to find your stationary points. So you have already found your stationary points in the previous video, which are -2, 37, and 2, -27. Okay, so the next thing, you need to have a table. So your table will consist of these attributes, interval x and also f prime of x. Alright, so you have -2 and also 2 as your x coordinate. So you are going to put these values up here and also here. And then your first interval is going to be from -infinity to -2, and then from -2 to 2, and lastly from 2 to positive infinity. Okay, and the next thing you need to do is to find a value that lies in between the interval. So for the first interval, I'm just going to pick -3, and then for the second interval is 0, and for the last one is 3. Okay, then you need to plug in these values of x into your f prime of x. So it's going to be 6 -3 squared minus 24. You just press your calculator and you will get 30. Okay, so 30 is a positive number, hence I'm going to write f prime of x over here as positive number. Okay, and then for 0, when you press your calculator, you will going to have -24, which is a negative number, so it is going to be a negative. Okay, and then for the last one, +3, you will have 30 for your f prime of x. So 30 is a positive number, hence I'm going to put positive over here. Okay, next, when you have a positive gradient, how does the graph looks like? Is it going up or is it going down? Yes, it is going up. You're correct. So which means that your graph will look like this. Okay, and then for negative, it is going down, and then finally it is going up. Okay, so do it like this. All right, so let's take a look at this first one you have over here. What does this line looks like? Is it a maximum or a minimum? Yes, it is. It is a maximum. It's over here. So which means that your -2, 37 is going to be a relative maximum. Okay, and your 2, -27 is going to be a relative minimum. All right. So write a conclusion. -2, 37 is a relative maximum, and 2, -27 is a relative minimum. Okay, now let's use second derivative test to determine the type of stationary points for our function. Okay, so our first derivative is 6x squared minus 24, and then our stationary points are -2, 37 and 2, -27. Okay, then you will need to have your second derivative. So your second derivative will be 12x. Okay, and then you need to plug in the values of x, this one -2 and also 2. You need to plug in into this second derivative. Okay, so for f double prime -2, you will have -24. Okay, and then for the second value f double prime 2, you will have 12 times 2 equal to 24. Okay, so if you take a look at these values, -24 is a negative number, so it's less than 0. Okay, if you have your f double prime less than 0, when you plug in your stationary points, the value of x for your stationary point, it means that your stationary point is a relative maximum. Otherwise, if you have a positive value like this one, so your point is a relative minimum. Okay, everyone, so you have basically two tests which can be used to determine the types of stationary points for your function. Okay, so for the first test, you need to use stable value, alright, and then substituting the value of x into your first derivative and look for the shape of the gradient. So if you have a shape of a gradient that looks like this, which means that your stationary point is down here, then it is a relative minimum. If you have a shape of gradient that looks like this, okay, which means that your stationary point is up here, then it is a relative maximum. Okay, and for second derivative test, you are going to find f double prime. So you need to substitute values of x into f double prime. Okay, so if it is greater than 0, then you have a relative maximum, sorry, minimum, and if it is less than 0, then you have a relative maximum. But if your f double prime x is equal to 0, then second derivative test cannot be used, which means that you need to use first derivative test. Now let's do example 2. The stationary points of the function are 1, 5 and 3, 1. Find the nature of these points using second derivative test. Okay, so you have two stationary points and then you need to find the nature of these points. So you need to determine which one of the point is a relative maximum and which one of the point is a relative minimum. Okay, so in order for you to do that, you need to first have your first derivative. Okay, and then you need to find your second derivative. Okay, after having your second derivative, you need to plug in the values of x, 1 and also x equal to 3 into your second derivative over here. Okay, so for the first value, f double prime 1, you will have a value of -6. Okay, so -6 is less than 0, which means that your point is a relative maximum. Okay, and then for the second value, for the second point, you have x equal to 3. So f double prime 3 is going to be 6. Okay, so 6 is a positive number greater than 0, hence your point is a relative minimum. Okay, so we have learned about stationary points. There are two types of stationary points, which are turning point and also point of inflection. Okay, our focus is only on turning point, which is a relative maximum and also relative minimum. Okay, and there are two tests that can be used. The first one is first derivative test and the second one is second derivative test. Okay, so that's all in this video. Don't forget to do your tutorial questions. Bye bye, I'll see you in the next one.